I'll note that when x goes, or when the graph goes through -4, 0, it goes through along a mostly straight, pretty straight, okay? And there's a reason for that we'll talk about in a minute. At 3, 0, the graph is nearly parabolic, close to x equals 3. Now, you get away from x equals 3 and the graph starts curving the wrong way on the left side. The right side, it probably gets too steep to be a parabola. So it's not steep enough after you get a little ways on this side, too steep after you get a little ways on this side, but close to x equals 3, in the neighborhood of this point 3, 0, we do seem to have something that, at least the way I've drawn it, looks like a parabola. We can confirm, in fact, that that should be the case. First of all, y equals x minus 3 quantity squared would be what? What would the graph of that expression be? It would be a parabola with vertex at 3, 0. Just a standard y equals x squared parabola shifted 3 units to the right. So we'd have a parabola with vertex 3, 0. Well, that's kind of what it appears we have. We don't know exactly what the parabola is, because there's going to be some factor out in front of the x minus 3 squared, but it's much like that particular type of parabola. So we can actually determine exactly what parabola that would be. Y equals quantity x minus 3 squared times x minus 1 times x plus 4, close to, when x is close to 3, that's going to be close to 3 minus 1 times 3 plus 4 times x minus 3 squared. I substituted 3 for the x value here and here. Now I didn't substitute 3 for this x value because in this case, near x equals 3, this expression is sometimes decreasing, sometimes increasing, and at one point it's 0. Whereas these factors pretty much don't change a whole lot as we move from one side of 3 to the other. I'm not going to say too much more about that. There's much more that could be said. But we can now say that when x is close to 3, y is close to, well, this times this is what? This is 7, this is 2, that's 14. Y is going to be close to 14 times the quantity x minus 3 squared. Now, you could actually take your graphing calculator if you wanted to do this, one of the few useful things you can do with a graphing calculator, but it's quite useful. You don't use a graphing calculator to construct this graph. You construct this graph by using these principles. The graphing calculator can be helpful in confirming that you got the graph right, but it's not the authority. The authority is what you understand about how these graphs are constructed and about these properties of graphs of factored polynomials. Still, if you graph this function and then graph this function, y equals 14 times the quantity x minus 3 squared, you'll see that near the x equals 3 point, these graphs are almost identical, but that the parabola then starts curving above the graph of your polynomial on this side and stays very quickly below the graph of the polynomial on this side. So the polynomial is higher than your parabola over here. The polynomial, it will be lower than your parabola on this side. So you'll see how the polynomial graph is actually not quite symmetric at the x equals 3 point the way a y equals x minus 3 squared parabola would be. Now, we can do something similar over here. I said this was nearly linear. When x is close to -4, we get y equals -4, well, just plugging in -4 for everything but the x that we have here, because this is the factor that causes us to go through 0. We find that the graph should be close to the function -21 times the quantity x plus 4, or negative 21 minus 84, and I seem to have not written my x. Negative 21 minus 84, that's not right. It's negative 21x minus 84. Let me fix it. Okay, again, substituting negative 4 for x here and here, but not here, we find that this expression is close to negative 21x minus 84, near negative 4, 0. Meaning that if you were to graph the linear function negative 21x minus 84, y equals negative 21x minus 84, would have a slope of negative 21, a y-intercept of negative 84, down here a little bit off the graph, and it would look something like this. So that line could be extended to the intercept down here at negative 84. So we conclude that this being a linear function, that the graph is nearly linear as it goes through the 0 at x equals negative 4.